The last concept for this chapter is theoretical yield and percent yield. The amount of product formed when 100% of reactants are reacted to form products based upon the amount of limiting reagent is the theoretical yield. That's basically what we're doing in the last couple of problems, calculating theoretical yields. All right, and then the extra thing added here is percent yield. So you expect a certain amount to be produced, but if you get less than that, what percentage is it? Okay, and the percent yield is the actual yield you obtain divided by the theoretical yield times 100%. So example 518 on page 236, methanol, CH3OH, also called methyl alcohol, is the simplest alcohol. It is used as a fuel in race cars and is a potential replacement for gasoline. Methanol can be manufactured by combining gaseous carbon monoxide and hydrogen. Suppose 68.5 kilograms of carbon monoxide. So we can say the mass of CO is 68,500 grams. Is reacted with 8.60 kilograms of hydrogen. So the mass of hydrogen is 8,600 grams of H2. Calculate the theoretical yield of methanol. All right, so we need to make an equation for this. So first of all, we have carbon monoxide reacting with hydrogen to make methanol. And first we need to balance it. We have one carbon, one oxygen, two hydrogens to four hydrogens. And so we need a 2 in front right there, and it is now balanced. All right. We need the molar masses of everything here. So the molar mass of CO is 28.010 grams per mole. The molar mass of hydrogen, which we've seen multiple times now, is 2.0158. And the molar mass of methanol is 12.011 plus 4 times 1.0079 plus 15.999. And it's 32.042 grams per mole. All right, so we've got the molar masses, we've got the balanced equation. Now we just need to do the math, okay? So we don't know what the theoretical yield is, we don't know what the limiting reagent is, and so let's actually figure that out. All right, so we have 68,500 grams of carbon monoxide. Let's figure out how much methanol there should be produced if that carbon monoxide is used up. So we divide by its molar mass, 28.010. Multiply by the mole ratio, 1 to 1. And then multiply by the molar mass of methanol, 32.042. All right, grams of CO cancel out, moles of CO cancel out, and moles of methanol cancel out, which means we get a mass of 78,000 78,000, and it should be to 3 significant figures, 78,400 grams of the methanol if we're using carbon monoxide. Now, if I'm using the hydrogen, we've got 8,600 grams of hydrogen divided by its molar mass times the mole ratio of methanol to hydrogen. And it's 2 moles of hydrogen. And then again multiply by the molar mass of methanol. All right, grams of hydrogen cancel out. Moles of hydrogen cancel out. Moles of methanol cancel out. And we get 68,000. Again, it should be to 3 significant figures, 68,400 grams of methanol. And so this says calculate the theoretical yield. So our theoretical yield, Ty, is 68.4 kilograms of CH3OH. Then it says if 3.57, and I'm reading right here, times 10 to the 4th grams of methanol is actually produced, what is the percent yield? All right, so the percent yield is the actual yield divided by the theoretical times 100%. So all we need to do is take that 3.57 times 10 to the 4th, and that's grams of methanol, 35,700 grams, divided by 68,400 grams of methanol. Oh, look, grams of methanol cancel out, times 100%, and we get 52, should be the 3 significant figures, 52.2% yield for this. And that's how you find the percent yield of a reaction. All right, that is it for Chapter 5. Next we'll do Chapter 6, which is on the types of chemical reactions and solution stoichiometry.